Hi there, my name is Mannat and I'm going to show you the super hydrophobic surfaces demonstration. Disclaimer, this person is a trained scientist who has all the required personal protective equipment necessary. Please be careful if attempting at home. For this demonstration, I will be using the following materials: 2 cans of hydrophobic spray, 1 base coat and 1 top coat, a viscous liquid such as flour and water or honey or something else, food coloring, a tray, a funnel, a bucket, a small plastic container, magic sand, water, and squeeze bottles. This demonstration shows us polarity as a characteristic of water and other substances. Water is the perfect example of a substance that is polar, meaning it has 2 opposite ends with a positive and a negative charge. Hydrophobic substances hate water because they have no charge, so they will stay away from it or refuse to bond with it, such as oil. Hydrophilic substances, on the other hand, love water because they also have opposite ends with different charges. Hydrophilic substances are attracted to and will bond with water. Okay, so here I have a tray that's divided into 2 sides. On one side, I've sprayed a hydrophobic spray onto it, and on the other side, I haven't done anything. So this is just without the hydrophobic spray. Here, I have a squeeze bottle that has water and blue food coloring in it. So I'm going to squeeze some water onto either side of the tray, and we're going to just notice how the water interacts with one side of the tray without the hydrophobic spray versus the other side that has the hydrophobic spray. I'm going to lift it up here and we're just going to watch. In this demonstration, we have half of a tray that is sprayed down with hydrophobic particles while the other half is left alone. So when we pour water or any liquid onto the tray, the water just slides off without making it wet. This is because the added layer of hydrophobic particles keeps the water away from the surface and ensures that the water doesn't make it wet like it usually does. On the other side, that has no spray, the water just stayed there on the surface like it would settle on any dish. So here I have a large container filled with water and nothing else, and here I have a smaller container with magic sand, which is essentially just hydrophobic sand. We're going to notice that as I add it inside the water, how it interacts with the water versus in the air. And here I have a plastic spoon that I'm just going to use to add the magic sand into the water. So I'm going to open this container. And here it is, purple color. So as you can see inside there, it doesn't just dissolve inside the water. And I'm going to add the rest of it here. So as you can see, as it goes inside, some of it is settled on the surface of the water, and then the rest of it falls inside and makes this very globular structure here. This is not how normal sand usually acts, because normal sand would just dissolve inside the water, and some of it settles down on the top before it goes inside. The reason why this happens is because the sand is hydrophobic, and so it won't dissolve in the water because it hates water. It'll just form this globular structure, and then it won't dissolve, and it'll just stay there. However, as we bring it up, because it's hydrophobic and it doesn't interact with water, it's still perfectly dry when we bring it out. So just as you can see, it's dry as it comes out, and it doesn't form like a big doughy structure like we usually use with flour. As you can see, it's very dry. So here I have a funnel, and I have 2 different sides of it. I sprayed one side with a hydrophobic spray, and the other side doesn't have anything on it, so that's just no hydrophobic spray. There's a mason jar underneath it that I'm going to settle it on, and here I have another mason jar with a mixture of just flour and water that I've prepared, and then a plastic spoon that I'm going to use to add this mixture into here. So we're going to notice the difference between when I add the flour and water mixture on the non-hydrophobic side versus on the hydrophobic side. So as you can see here, it just settles down normally. If you add flour and water to any kind of container, that's how it acts. Whereas if I put it on the hydrophobic side, it's a lot more likely to just slide off because it doesn't like interacting with hydrophobic things. Water is hydrophilic, and this has water inside it, whereas the spray here is hydrophobic, so then they try to stay away from each other, and it's more likely to just slide off. Thank you for watching the hydrophobic surfaces demonstration. Enjoy the rest of your time at FUNweek.